Cool. Okay, so my name is Dave Pearce. I'm from Victoria University of Wellington in New Zealand, and I'm going to talk to you about my programming language, which is Whiley. I don't know, has anyone actually heard of Whiley? No. Oh, really? Yeah, just now. Yeah, it's a research language, but it's kind of interesting, and I hope you get an idea of why I think it's interesting. And it definitely does do some stuff which I don't think you will see in any other programming language, pretty much. And we're going to see a demo, so you can believe it actually does do something. It's actually real to some extent, but it's definitely a work in progress. And if you download it and try and run it, you will have some problems, I'm sure. But if you're interested, just email me. Okay, I haven't put my email address up there, but you can get me on Twitter. And yeah, I'm definitely interested in finding people who want to work on it and just generally doing stuff. That'd be cool. So yeah. Okay, and as the presentation goes, please ask questions. I really like a much more informal kind of presentation, talk, not a lecturing kind of blah, blah, blah. So please ask questions if you're stuck. Yes, first question.
How are you working on it?
How good? Okay, so there's some statistics. In fact, if I had the internet, I'd bring up my Olo page, which would tell me all the exciting stuff. I started it in about 2009. The blog went live about mid-2010, and that's about the same time the GitHub repository started. So, what are we talking? Almost 3 years, I guess, something like that. It's like 100,000 lines of code or something ridiculous now. It's like makes my head hurt. I did have an exciting day when I was looking at Olo. I found this, Olo. It's great for. It looks at GitHub repositories if you haven't used Olo, and it just pulls that statistic so you can see your lines of code and how they change over time. It's great. So my lines of code kind of went this, and then one day it just went like this, and I was like, what the hell did I do? Oh yeah, I checked in a file that's 70,000 lines of code. Awesome! I didn't write it though. Fortunately, it was automatically generated, but that stuff my statistics. So yeah, so you can get me on GitHub. You can check it out there. You'll see there's lots of stuff going on. I do tweet and I write blogs, and those of you that read R programming on Reddit, you'll see me occasionally. I do post there and I blog there as well. So, yeah, okay, cool. And I'm going to basically start with a kind of introduction to the language, kind of quick-ish introduction, and then at some point we're going to jump into the demo. But like I said, please ask questions. That's the best way to figure out what's going on. Because my kind of view of Whiley is kind of, disturbingly biased by it. It just all makes sense to me, basically, and that's the problem. Okay, so the first absolutely most important question is, why the hell am I making a new programming language, right? This is totally crazy. Why would I bother? Well, I am an academic, okay, so, that means I can do whatever I want, right? But I do have a plan. There is a plan here, and I'm interested in this thing here, verification, right? This is what I'm about, okay, which is compile time verification, compile time checking of pre and post conditions, okay? And we're going to see that working in a moment. And so pretty much the whole point of the language is to make that happen, right? And almost all of the decisions I've done have been about making that easy to do. And in a language like Java, verifying Java is really, really hard for lots and lots of reasons, particularly lots of references and aliasing, modulo arithmetic, interesting concurrency semantics, lack of pure functions. There's just heaps and heaps of stuff that make it basically impossible. And so I kind of basically had enough of Java in that respect and decided to build my own language, Whiley. And it compiles down to the JVM, and you can interrupt with Java, actually. So you can call Java functions, and I've got a game in Tetris where the GUI is done in using swing, and the logic is basically in Whiley, and that actually works quite well, surprisingly well, in fact. So verification is basically really hard, and Java makes it really harder, much harder, and so I gave up on that and designed my own language. And I don't know if any of you has anyone used ESC for Java? Has anyone heard of that tool? No. Or JML, Java Modeling Language? No, they're research things, I guess. So ESC for Java is pretty cool, because that does try to do this verification stuff for Java, and it's actually not bad. But it's also not good in a lot of ways as well. Like it crashes and it doesn't support generics and blah, blah, It's like stuck in 1.4 land. But it's not a bad effort. And you can download that and have a look at that. Anyway, okay, great. Okay, so what's interesting about Whiley? Well, okay, so I designed it for verification, but it turns out it's got lots of interesting features, which to me just made lots of sense. But looking back on them, go, they are unusual. things like flow typing. So for people who use Groovy, I think there's a few people who use Groovy here, right? You know that Groovy 2.0 uses has got a flow typing checker, right? No? Okay. It's one of the things, new things about Groovy. Where basically what they want to do is they want to do type checking for Groovy. But the thing is that because Groovy is an untyped language, you know, you can write lots of crazy stuff. You can like write a variable, you can go x equals 1, and then the next line you can go x equals, you know, inverted commas, hello, and that's all fine in Groovy. And so to type check that, you need to use flow typing, where you basically allow variables to have different types at different points. And it works quite well, actually. And I've got some other things. So I've got value semantics, verification, pure functions. I'm trying to think what would be what the right word for that is. Structural typing, you might have heard of. Yeah.
So what's the difference between flow typing and Whiley typing?
So flow typing, it's definitely it's static, it's strong, but it uses a flow-sensitive algorithm. So it means that we're going to see some examples actually, but it means things like the type of a variable can change, and if I assign to the variable, then the type can change to anything based on what I've assigned it to, right? Whereas in Java, the type of variable is given by the declaration. You know, so I'm stuck with that single type. So if I declare temp as being an integer, and I want to have a temp that's string, well, I've got to have a string temp2 or something like that, right? You know, whereas in flow typing, I don't have to do that. Some other things, it's got unbound arithmetic, and making that go fast on JVM is a bit of a challenge. And I'm going to try and sort of talk about some of these things, but I'm pretty much going to pick on flow typing verification because I think they're the most interesting. Yeah?
No, just so we're on the same page, when you say verification, what is it that you mean? What's the target you're aiming for?
Okay, that's a good question. So what do I mean? So you can write pre and post conditions. So I can say things like we're going to see this. But you can say an integer is greater than or equal to 0, or this integer parameter is less than the size of this list, and it will tell you at compile time if that could be violated. Right? That's what it means. And so things like, you know, out of bounds errors, divide by 0 errors, all of those things, the idea is they don't exist.
Designed by contract.
Yeah, designed by contract. Exactly. Yeah. Yeah.
In previous slide, you mentioned you can call the Java code. Does it have to be through the some kind of native interface?
Yeah. So at the point of calling Java code, all bets are off, right? Yeah, sure. That's true. I mean, what can I do? Right? There's not much I can do. The only one thing you could do, which I don't do at the moment, is actually put in runtime checks at the point of the call. So at least you'd know at runtime when you made the call into Java code if there was a problem. But I don't even do that now. So yeah, you're right. That is, yeah. What can I do though? There's not much I can do about that.
So is this mainly focused on mathematical verification and analysis and modeling and things like that?
You mean what would be the use case of this language? I guess.
It seems like it's weighted towards mathematics.
Well, I wouldn't. That's not the word I would use. Safety critical systems. Okay. Yeah, that would be the word.
Yeah.
It's kind of similar.
Systems?
Sorry.
Trading systems.
Yeah, potentially. I mean, those would tend to be real time, so it would certainly have some benefit in that space. I'm not sure that it would address all the issues that you have with those kinds of systems. But so there's probably the most comparable. There's a language which is called Spark Ada. If anyone's heard of Spark Ada, they use it to do software in the A380 and the Boeing 777 and this kind of stuff. There's a company in the UK in Bath called Ultron Praxis that do that, and so they've got a very similar system built on top of Ada. But it's quite simplistic. My goals are more ambitious, I guess. But I think, personally, this is the kind of language I would actually like to use. I mean, it means I can write my the invariants on my data structures explicitly, and the compiler will tell me if they're broken. And you know, I do that anyway now, except the compiler just doesn't tell me when they're broken, and I have to figure out the hard way.
And you have to write tests explicitly to check that.
Yep, exactly. So, you know, I think it could be a beneficial in general. It remains to be seen, right? I mean, in some sense, part of the reason I'm doing this is it's like a proof of concept. Can it actually be done? Can we make a language that people actually use that do this? And if we do that, what happens? And maybe, you know, after lots and lots of years of effort, the answer is nothing happens, no one cares. Oh well, at least I tried. You know, what can you do? Okay. I mean, for me, you know, I get to write papers and go to conferences and all this kind of stuff. So, you know, I can't complain too much. Okay, so I think it's quite useful to start just by looking at some of the types, because I've got some unusual types, some of which you probably won't have seen before, some of which you will, and this is only some of them, it's not all of them, there's more stuff. But we've got a bunch of the obvious things, like int and real, which is those are both unbounded, so unbounded integers, so there's no wrapping around. And these are unbounded rational numbers, in fact. We've got characters, booleans. We've got null, which I still like despite everything. But we've got a nice story for null. And we've got this thing any, which in a sense is a little bit like object, but it's basically the type of everything. So anything can go into any, basically. I don't really have objects in the classical sense. And we've got built-in collections, so we've got a list. So that's a list of integers, a set of strings, and a map of integers to strings, right? Or a dictionary, if you're in Python terms. We've got records, so this is just a record with two fields, x and y. And we've got a tuple, so this is just a pair. And you don't even really need to use the braces when it's not ambiguous. And I have destructuring assignment, just like in Python as well. So it works quite well. And so that's, probably mostly okay. And the interesting ones are these unions, intersections, and the negation types. And a lot of the time you don't see these two, but the union types you see quite a lot, and they're really useful. If you're into, I don't know, functional programming languages, they sometimes call them sum types. But in fact, some types are disjoint, so these are not disjoint. But so this would be, for example, the type of integer, the type which includes the integers and null. Okay, so the cool thing about this is I can express what references are already in Java, which is the possibility to reference an object and null, and so then I can check specifically if null is there, and I won't let you do stuff to this thing if the possibility of null being there, right? You've actually got to get rid of null before you can do anything. And we'll see an example to make that make a bit more sense.
Is that like the Elvis operator in Ruby?
No, it's not. I mean, it's sort of, because it's a type system thing, right? So it forces you to do type tests. So basically this thing, I can't do anything with it until I've type checked that it's not null. And then I can do whatever I want with it. So it is different.
Can I ask, what's the difference in semantics between a record and a map?
The difference in semantics, I guess it's about typing, mostly. So if I dereference a field, I know exactly what type I get back. Whereas with this thing, well, I always get a string, but I just get a string, right? Whereas with my record, I could have an X int and a Y string or something like that.
So the map values are limited to strings, or
no, I could put any types.
Any to any.
Yeah.
But you get back in any, you don't know what type it is.
Well,
it's a difference.
Yeah. So that's probably the major difference. In principle, you can't do this yet, but really what I would like to do is basically be able to take this and then cast it into this, if you like, convert it into this. Because, I mean, they're obviously very similar. And that would be quite cool because it would give you a way to reflect on a record. If you've got a record and you didn't want what was in it, you could then treat it as a map and then iterate through its keys and stuff. But anyway, that's all to be done. Okay, cool. Okay, so hopefully that gives a start. Oh no, I haven't talked about the negations and the intersections. Intersections are like union, except it's both. So this doesn't even make sense. This is basically void because it's an integer and it's null, and there are no integers that are null, so that's just void. And this is a negation, which means it's everything except that thing, right? So it's everything except the integers. Okay, and you mostly don't see these types. So you can actually write them, but they do come up in the flow typing in particular, and we'll see that. Okay, so I'm going to start by talking about flow typing, and then we're going to do the demo. Okay, so this is the very simple piece of Whiley code. You'll notice it does look like Python. I guess that's not a coincidence. I like Python syntax quite a lot. So it's indentation. I'm using the colon to indicate that it's the start of a block, and all that kind of stuff. And the example is supposed to show flow typing. So the first thing you notice is that R is not declared. But there's no declaration. I've just assigned it. And the system basically goes, okay, I'm assigning R an integer, therefore R's got type integer at that point. And I then go through the loop, and I'm adding to integer, and I'm going to return it, and that's all fine. And pretty much all you ever do is you write types with the return value and the parameters. And you basically don't write types in any other position unless you're writing like a type test. That would be the other one case you do. And so this is a fairly simple piece of code, and we're just basically going to go over the items and add them all into my accumulator and return it.
Well, what happens if the type of item happens to be a string? It's a list of strings.
Yep.
And we've got a string with binary operator against an integer. How does it resolve that? Does the compiler Say that's not allowed? Or?
So this, yeah, if it was a list of strings, in this case you would get a syntax error. But in principle it can handle that because the type of R can be an integer. If I assign it an integer there and then I assign it a string here, then after the loop it would be an integer or a string. So you can do some stuff, but it won't handle trying to concatenate and add to the same thing. That it won't resolve. It will go, okay, that's an error. I don't know what it is.
So you don't have any boxing or typecasting automatically a number into a string or those sorts of things that other languages like to?
No, not in certain situations. Let me think about this just for a second. I see where you're going. I don't think it would work. Yes, I do. In fact, if I knew R was a string and I was concatenating to a string, then yeah, it would work. But because the first time I look at this loop, R is not a string, it won't type that.
So you'll get a compiler.
Yeah, you will. But yeah, I see where you're going, and it does open up lots of questions. And the reason why my type system is so flexible is to support a lot of those interesting cases. Yeah.
Do you like operator overloading or anything like that?
Not at the moment. I'm a fan of operator overloading, so I see that on the agenda. But yeah, it's just one of those things in principle. Yeah.
So you don't declare variables. So say you make a typo inside your for loop there, say R1 equals R plus item. Do you get an error with that? Or
no, that would be fine. It just would be dead code, basically. If this turned out to be R1, then that would just be dead code.
Yeah.
And yeah, it would compile. And yeah, is that ideal? Interesting question. If this was R1, then it would be an error because R1 would be undefined, potentially undefined.
Yeah.
So yeah, that's one of the potential downsides. I'm not, I think I accept that, to be honest. But I just kind of like the aesthetic, Yeah. Trying to think if that's ever happened. I don't know if it has ever happened to me yet. Yeah.
Just following up on that, really, there are some compilers that will actually throw out the fact that you've not actually used this bit of code.
Yeah. Basically, we'll say this is dead code.
Yeah.
What's the answer to this question? With the loop,
You just get a warning.
I'm trying to think what it will actually do. It won't. I don't think it will give you an error. I think it's going to be okay. It's only if the code is unreachable. So like in Java, it's only if the code is unreachable that it will actually throw an error. So for example, if it's after a return statement, after a throw statement, that kind of stuff. Otherwise, it's okay. But yeah, it is essentially dead code. So yeah, I could potentially try to trigger warnings. That might help in that case. Don't know. You've got to weigh up the pros and cons, haven't you, right? Okay, anyway, all right. So a little bit more. So this is a slightly more complicated example. I had to sort of shorten the field names. I wouldn't want to have such short field names really. But basically we've got a circle, which is a point, x and a y, and a radius, r in this case. And then we've got a rectangle, x and y, and it's got a width and a height. And then we've got a shape, which is a circle or a rectangle. Okay. And then basically I've just got this area function, takes a shape, and it's basically going, if the shape is a circle, then we're going to calculate its area, which is pi times r squared. And you notice that I don't have to cast or do anything there, it automatically retypes it for me. So that's the flow typing algorithm going straight in and realizing that because S is a circle, it means it's got this field R straight away. And likewise on the false branch, because we know it's not a circle, that means by process of elimination it's got to be a rectangle, and so that means, okay, yeah, we've also, on that side, we've got access to the width and the height fields, so we can just use those straight away. So we don't have to do any horrible casting after our instance of tests, basically. And in fact, this is where you see the negation types, although you don't really see them, but they're there. Because basically what's happening is it's taking this type and intersecting them to compute the type of S on this branch. And on this side, it's taking this type and the negation of this type and intersecting them to compute the type on this branch. And what it means is, I don't actually have to write circle here. I could write, in this case I haven't really got enough interesting stuff. Let me think, what could I write that would be interesting? Are there any good ones? I don't know if there are. For example, I could write, is it a circle or a rectangle, for the sake of argument, and then we get a compile error here because S would have type void, for example. But if I had some more interesting types, like say the field x could potentially be integer or null, then I could say if it's a circle, and on this side it would then have the possibility when x was null as well, because that would not have been taken out. If that makes sense. Don't worry too much. But it's quite powerful, I guess, is the upshot. And you've got to treat, basically you treat types as sets, and the intersections are set intersections and the unions are set unions. And I can literally pluck out different subsets as I want to. They don't have to be named explicitly at all.
So is this...
Yes?
Is this similar to polymorphism? It feels a bit like that.
Is it similar?
In a different way.
I guess it's similar in some sense. There's no dynamic dispatch in the same sense in my language, but I could have, in particular, if I had a switch statement, that would be really nice, and I could do pattern matching on my switch statement straight away. That would be really cool. I don't actually support that yet. I do have a switch statement, but not over types, and that would look really nice. Yeah. So it's similar. Similar, yeah.
Are you covering structural typing later, or should I ask that?
It's right at the end.
Right.
We might not get to it. Yeah, so you start to see the structural typing stuff here. Basically, these defined statements are exactly what they look like. They're macros, right? But they're typed macros, not like in C. And so they actually expand. The compiler just expands them before it even tries to basically compile them, pretty much. And so, yeah, you get this structural typing thing. But I'm not going to talk too much about that, actually. Yeah,
but does the language support like an object-oriented approach to that example? So, in the arrow sense, your circle object would just return pi squared, and your rectangle object, so that one line of code as well, return like width by height.
Okay, so the answer is yes, it does, but it's a little bit more like how you do it in C. Okay, so I have lambdas, I guess, and function pointers is what I call them, for a better word, maybe functors or something. And so if I wanted to define, let's say, a shape which has an area method, I'd define a record, and that record would have a field, and the field would be a functor of type, in fact, it would just be no parameters, return real. And then each of my instances, my objects, would then provide a value for that function pointer, which would point to their specific area calculation. So it's like sort of going backwards. You're sort of deconstructing objects into the base things that they are.
Yep.
Does that make sense? Yeah? Yeah. Which I quite like, because then there's no confusion about what's going on. There's no, what does inheritance mean? Well, it doesn't mean anything. Why? Inheritance doesn't even exist. It just means if it's got the right fields, then it goes in. It's like duck typing, but statically typed. Yeah. Okay, cool. So, yeah, good. Lots of questions. Okay, so here's another example. This is quite a nice example which shows off the union types quite well. So here we've got classic index of method. Right? So in Java, the index of method returns integer, and it uses -1 when there's an error. And basically what we're doing is we're looking for that character, the index of that character in that string, and it of course might not be in that string. And so in my system, I'm going to return integer or null. So null is the error case. Right? So if there's no character, I return null, and then basically we first take the index, we get the index of the string and the character in this example, and at this point right here, we can't actually do anything with what we've got because it might be null. And if we try to add to it or something like that, the compiler is going to complain straight away. And so we've got to do a type test. In this case, if it's int, then okay, we can do stuff. And it will automatically retype it to be an integer. Otherwise, well, obviously the thing didn't exist in the string, and so we've got to handle the error case however we would handle it. But the key is the compiler basically tells you. There's no, oh, I forgot to handle -1. Or in C, I don't have to worry about null because the compiler just doesn't care about null anyway. It's none of that stuff, right? And so basically, there's no null pointer exceptions in my language at all, just by construction. You can't have it. It doesn't make sense. And for me, that's kind of the right way to solve this problem, I guess. Yeah. Cool. Okay. So what else we got? Let's have a look. Okay, so just one more, then we're going to zoom on to the, how we're doing. We're going to zoom on to the demo. So I've got recursive types as well, which basically means you can define, recursive data structures. So here's an example. It's just a linked list. And I'm basically defining a linked list as being null, empty list, or a link. And the link is just a record in the data field. I would write data if I had space. or a next pointer to a linked list. And then I've got my sum, and I'm just going to sum through my linked list. Okay, if L is null, then I'm going to return 0. Otherwise, I'm going to return L.dat. And you'll notice that it's retyping variable L at this point here, because it knows that that's a type test. So that it knows that L has got type link at this point. Whereas up here, it's got type null or link, right? Whereas here, it's got type link. And so I can go straight into that, and that works really nicely. Yeah.
How does it know linked list is a pointer to a linked list? Like the primitive types int aren't pointers, obviously.
No, so it's not.
List, is it an implied pointer there? How does it figure that out?
It's not a pointer.
It's not,
basically.
You just said pointer to a linked list.
No, well, maybe I did say that. I don't know. It's easy to get confused. No, so in Whiley, they're basically, well, there are pointers, but I'm not going to show any examples that have pointers in them today. Everything has what I call value semantics. Okay, you can think of it a little bit like C++, where you pass, you can pass classes by value rather than by pointers to the objects and that kind of stuff. And so these recursive types are in fact values in the true sense of the word. If I try to modify the linked list, no one outside of that function will see that modification. I can return the updated version, yeah, that's fine, but no one will see it. And so, in fact, making the type system work well with these recursive types when they're not pointers is actually slightly tricky, but it works, and it's quite nice.
So does the language have references?
It does have references, yes. But yeah, we're not going to see them. I guess they're probably the most immature part of the language, to be honest. But yeah, it does have references. The whole point of the language is to absolutely minimize when you use them, because those things just kill verification. So I sort of think of a language as having this really thin imperative, or sort of object-oriented outer layer, I guess, and it's really a functional core in the middle. This is a functional. What we've seen so far is just a functional programming language. It just doesn't look like it. Right. Yeah. It's kind of a sneaky plan, right? Because for verification, it's got to be functional. It's the easiest way to handle all the problems. But I don't like functional programming languages for the most part, as I've seen them. I like things that are like this. It's just my thing. Okay, cool.
Right.
Yeah, sorry.
So for recursive types, those defines need to be in that order, or can you do either way around?
Yeah, it can be either way around. It's all good, and I can have, I can have defines in the same file. That's going to be fine. In fact, I can have defines across files, but I have to compile them at the same time. Okay, that's pretty much the only restriction. So yeah, it's quite powerful in that respect. The compiler, yeah, there's 100,000 lines of code. It does lots of stuff, and it's based on my earlier project, which was a Java compiler, which is called JKit. So I took a lot of influence from the way that compilation in Java works into this compiler, in fact. That's another story.
Well, that's another question I have, actually. Is the Whiley compiler written in Java?
Yeah, it is at the moment, yes. Yeah, I would like to rewrite it in Whiley. I probably could, but it's just... I guess the thing is, when you've got a big code base, I'm sure many of you know, the thought of rewriting it in another language and then having to debug it for the next 3 years doesn't fill me with that much excitement.
Verification, so you don't have trouble.
The verification doesn't. Yeah, when it works, I'll do it. Okay, it's on my agenda to do. There's some components that I will basically start to do progressively, but yeah, I've just made too much investment, unfortunately. But I have got some benchmarks. Yeah. Okay, verification. Right. So demo. Okay, so I'm going to sit down and I'm going to try this demo. And the demo is an opportunity to ask questions, right? We're going to run my Eclipse plugin, and I'm going to show you some stuff, which I want to show you, but hopefully there'll be questions. You'll have some questions, and feel free to just shout them out, and we'll just see if it works. And sometimes it might even crash, okay? In fact, probably will. All right, cool. Is that going to work? Let's just make this a bit bigger. Look at this thing. Okay, sweet. And we'll bring this down here. Okay, so this is my Eclipse plugin. Anyone written an Eclipse plugin here? No? Nobody? Oh, okay. Well, it's running inside Eclipse, so when it crashes, we can even look in the console and see the error messages right here. But at the moment, it's okay. So let's start. I'm just going to go through my basic routine. Okay, so we'll start with this. This is my basic program, and that's fine, not a problem. And then we're going to do a few things. We're going to add a post condition. So basically, the post condition says it must be the case that the return value, indicated by $, is greater than or equal to 0. Okay, and so I'm taking in an integer. Integer could be negative, so this program should be an error. So when I save it and the compiler recompiles, we should hopefully see an error message. Otherwise, I get upset. Oh no, we do. So, and it just says, "Well, no surprises. Post condition not satisfied." All right, and so then we've got to ask the question. Okay, well, what can we do? Well, we want to add a precondition, which is going to say x is greater than or equal to 0. In this case, and then hopefully the error message goes away, but the underlining doesn't. Why doesn't the underlining go away? Okay, I don't know why Eclipse is doing that. That's just annoying, but anyway. I think there was a reason. What did I figure out the reason was? No, let's not worry about it. Okay. So basically, the precondition in this case matches the postcondition. So I know that that's going to work. But I can do a few other things. So I can say, let's do something like this. Right? In this case, we should still not have too much problem. That looks okay. If I go like this, I should now see an error. Right? And we see an error postcondition not satisfied because the precondition is saying, okay, x is greater than or equal to 0, and then it's saying, well, the value must be greater than 0. Well, that doesn't make sense, right? But we can do some stuff, right? We can just go, okay, well, return 1, right? No problem, sweet. Hopefully the underlining will actually go away now. Yay! Awesome. Because now it knows that the return value meets the specification. And that kind of works quite nicely. Okay, so the thing about those pre and post conditions is that they get really long, really, really quickly, I discovered. So I use my macro system to kind of get me out of this. So I'm going to find a natural, think about how to do this. Okay, so a natural is basically an integer where that value, indicated by $, in this case, is greater than or equal to 0. All right? And so we can basically go back. Let's go back in time. And right, in this case, so now, effectively, what we've got is a post condition that the value returned must be greater than or equal to 0, and of course, we haven't got a precondition because x could be any integer, and so we end up with this error message. The error message is slightly different just because it comes out of the macro, but it doesn't really matter. And so we can either go requires that say x is greater than 0, that's going to be fine, or we could even just say go like this, and so that the x is a natural, and that should be fine as well, and that's going to work fine. And in fact, what the compiler actually does is it literally just expands the macros. So there's no difference between writing that and writing requires x is greater than or equal to 0. It's exactly the same thing. Cool. Okay. Right. So let's try running some more functions. So let's do this one. Okay. So we start with absolute. So this is going to give me an error. So I'm just going to go if x is greater than or equal to 0, return x, else return minus x. And hopefully that's going to work fine. Yeah, okay, so that's cool. So that's just the absolute function. I know it always returns something that's greater than or equal to 0. It's just how it works. What else can we do? Okay, let me think. What other exciting stuff do I want to do? Let's try something like, we can do max. Okay. This is quite a complicated one, actually. So let's just start by going return x, okay? So it's going to be broken to start with. The first thing I need to do is actually write the pre and post condition, or the post condition, I guess, in this case. Ensures $, equals x or $, equals y. Okay, so in that case, that's going to be fine, but that doesn't define the maximum of 2 integers yet. We need more than this. But it's definitely got to be one of the 2 parameters. And we want to say, and I'm just going to try and wrap this, and x is, let's see, and $, is greater than or equal to x, and $, is greater than or equal to y. And hopefully that is now going to be, give me an error. Yay! Okay, so it should now say post condition not satisfied. And so it's basically figured out. Does that make sense, what I've written? No. Yeah? No. Someone said no. No, go on, it's okay. So basically, yeah, I'm trying to define the max function. Okay, and so I've written this post condition, which is basically the specification of what max is supposed to do, and max has got to return one of the 2 parameters, right? That's the first point. So either the return value is x or the return value is y. So that's the first point. And the second point is the value that it's returned has got to be greater than or equal to x and greater than or equal to y. So it's got to be big, at least as big as the biggest of them, right? And so that's my specification. Now I've compiled it, and it's saying, well, that's wrong. And that is wrong, right? Because I'm just returning x. Well, if x is the smaller of the values, then it won't meet the specification. So let's see, what can we do? Let's go, if x is greater than y, let's do return y, because that's obviously broken. And then we should hopefully see another error. Awesome. Post condition not satisfied. And finally, we can just go like this, and fingers crossed, then it works. Off it goes. Awesome. There you go. So that kind of illustrates it. I think you can start to see, though, it starts to get long. There's no doubt. And I think there's a question mark for me as to how to deal with that to make it more manageable, you know? It's sort of, I think it's one of those things that from actually writing some big programs, I'll get a feel for how big these specifications actually end up being. Okay, so let's just do a couple more.
Have you thought of the concept of doing unions on values? So you could say, ensure return value is x or y, like you do with types?
Well, you can do that already because you've got this logical or. So I can say the return value $ equals x or equals y. So it kind of gives me the same
so you
thing.
Could do that?
Yeah, in fact we did. We did. That's right there.
No, I mean $ equals x or just single line or
No.
y. You know what I mean? It's like the
okay, that would be
semantics, not on types but on values.
Yeah. Okay. Yes, potentially. I think you could do that. I mean, it would be like a syntactic sugar or something like that. I don't see. It could be convenient. Yeah. So
it's like creating another type, a
yeah.
coincidental type.
Yeah.
Just has two values, x or y.
And
but that would require runtime.
Well, it would work
it?
for the specifications actually, because they're not operational in that sense. That would be a way to condense them down. Yeah, I agree. I haven't thought of that. So interesting. Don't know. Yeah, maybe. I have to think about it. Okay. Okay. Right. Let's do a few more. So let's try this one. This is where it gets kind of interesting. So I'm going to do sum. So has anyone done a computer science degree and they've studied Hoare logic or any kind of verification? Okay, you have a few people. And did you have to do loop invariants?
Yeah.
Yeah. Were they like a nightmare? Yeah. So you have to do loop invariants and Whiley as well, basically. That's the upshot. And we'll make this more interesting as we go along, but we'll start with the simple. Okay, so, oops. So let's go, what should we do? For x in x's, r equals r plus 1. Just trying to think if this is interesting enough. No, let's not do it like that. While I is less than the size of x's. So that's my index, and that's my accumulator. Okay. R equals r plus 1. No, plus x's brackets I. That makes more sense. I equals I plus 1. Return r. Okay. I think that makes sense. Does that make sense? Yeah. So basically, I'm trying to sum up the integers in that list. I'm going up through the list. I'm doing it just a while loop because it just exposes some more interesting stuff. And I guess some of the key things here are this operation right here is an interesting one. Okay. Because of course that could be an out of bounds exception. So when we compile this, the first thing we're going to see is index out of bounds could be negative. And this is where, for me, it gets interesting. It's basically saying I could be negative at that point. Now, if we look at that piece of code, we go, no, it couldn't. In fact, it couldn't, actually. But the way that Hoare logic works, we end up not knowing anything about I within the body of the loop. And in fact, there's some more advanced algorithms I can use, but it doesn't do that at the moment. So I end up having to write a loop invariant like this. And in fact, the compiler could infer this for me, and I would like it to do that. And that works quite well. So in this case, because we've got both I is less than the size of the list, and we've got I is greater than 0, that operation is fine. And we can just test that, actually. You know, it's always good to test it. If I do it like this, I would probably expect to see some kind of error. And yeah, I do see an error.
So is there any difference between saying where or just having like a Boolean and there?
That's a most interesting question. I don't think anyone's asked me that question before. In this, is there a difference? Yes, there is a difference. trying to think what it would. It actually is okay in this case, though. Nice. Nice. Yeah, no. Yeah, the basic difference is that when you have the loop invariant, it will assume the loop invariant here, and it will try to establish the loop invariant at the end. But with the condition, it won't. But the condition is enough, in fact, in this case, to prove it. So, yeah, no, pretty cool.
So is where like ensure?
Yeah, I guess so.
What's the difference?
What's the difference? Different keyword? I would like to use where consistently. I might move to a syntax where I don't have requires and ensures, and I do something like this. So let's say I wanted greater than 0, and then I'm going to, this is all very hypothetical, but anyway. I don't think it might be a bit longer, but I might move to a syntax like that, if that makes any kind of sense to you, where I'm using just where to express everything.
Yeah.
And so this is the precondition here, and this is the postcondition. And aesthetically, it makes sense. I'm not sure if practically it makes sense, but yeah. I sort of pondered that question.
Part of the niceness of separating them is blame, because a requirement is the user of a function is responsible for that constraint, whereas with the ensures, the implementer of the function is responsible for
well that's
so it's clearly assigning blame to the client or the supplier.
And that's definitely an advantage of the whole system, exactly. And
It's designed by contract.
Yeah,
it's more than just.
That's right. But yeah, so the syntax. Yeah, some questions. Okay, so now let's make it more interesting. So what did you do? Just I'm going to put it in the loop invariant. Think about that. So what am I going to do? I'm going to try and do this. Hopefully this is going to work. So I'm going to make this a. In fact, let's not do it. Let's do it the other way around, because that will give us the error. So I want sum to return a natural number. And if we sort of look into the future and we imagine that x's was a list of natural numbers, then we'd know that adding a list of natural numbers will always give us a natural number, basically, because there's no wraparound in this language, so you don't have to worry about that case. And so that's basically what I want to do. And it just turns out that the loop invariant gets a bit more complicated at that point. And we end up like this, and it's just going to tell me my constraint is not satisfied, and I need to write a loop invariant just to make sure that R is always a natural number as we go around the loop. Okay, now, I guess it's a bit technical why I have to do that, but it's just illustrating there is definitely overhead with using a system like this, but hopefully you can see there's potentially benefit as well, I think. And if you look on YouTube, I've got an awesome video of doing this, which I've sped up and put some cool music on, and it's like much more exciting. Anyway, okay, so that's pretty much the demo. I don't have any questions. Yeah.
Yeah. So in that example, the while is done at runtime and the where is done at compile time. Is that right?
Yes, that's right. Yep. So
no cost to getting the where.
No overhead. No. You can turn them into runtime checks if you want. And in fact, in principle, if the verifier, like the verifier, which is the thing that does all the sort of checking under the hood, has kind of got three states. One, it definitely knows there's an error. One, it definitely knows there's not an error. And then there's it timed out, basically, because it's quite complicated. And if it timed out, you could then turn it into a runtime check at that point.
So if that where was an double ampersand, then it would be runtime?
That is true. That is one difference. Yes, that's absolutely right.
So your code's going to run slower.
Yeah, I hadn't. Yeah, yes.
So the where is just a condition as you enter the loop.
It's a hint, like to the compiler, as to how to prove that this loop actually sort of does what you want it to do, I guess is the way to think about it. And in principle, the compiler can infer some of these invariants for us. Simple ones, especially like these ones we're doing here, it could actually figure them out. It's not that hard to do a static analysis of this loop body and figure that out, in fact. But there are some where it gets more complicated. Things like if you're like sorting a list and you're sort of part way through the list, the invariant has to say, well, everything below this point is sorted, but after it is unsorted, and that is more tricky to express.
So do you find yourself separating these functions out into smaller things so you can define these invariants?
I have to sort of give some context to that question. So the largest program I've written in Whiley is about 4,000 or 5,000 lines of code. It's a GIF encoder decoder, a PNG actually encoder decoder, so it does, I can't remember what the compression is, has zlib decompression. Anyway, The largest program I've verified in Whiley is probably like 100 lines of code, tops. So I don't think I've really hit that problem yet. I anticipate that makes sense. I don't have enough experience here. Yeah. Cool. Okay. How are we doing? We're doing okay. Should we jump back to the presentation? All right, let's do that. Cool. So that's verification. So I've got a whole bunch of slides. I'm just going to go straight through them because this is my backup if the demo goes wrong. And there's a whole thing here, which it does sometimes do. Okay, so I'm going to talk a little bit about value semantics and then a little bit about structural typing, depending on how we're going for time. Cool. Okay. So I have kind of mentioned this already, but if this is a method for just manipulating a point, right? The point is x and y, and I'm just going to add some deltas onto it, basically. And the key is that unlike in Java, this is not a reference to a point, it's just a point object. So as I assign to my point, you can imagine it as though I get a completely new point, right? And then I get a completely new point here again, and then I return this point. And so this thing that I had beforehand is completely untouched. And anyone who called it, anyone who passed the variable n to that method will not see any of these assignments, any of these changes. And I actually personally find that easier to understand, and I know my students do. But it obviously raises a most important question, which someone is dying to ask me right now. Go, the question.
There's no methods with side effects. Is that what you mean?
That wasn't the question, but that's an equally good question.
The answer?
That's an equally good question. So the answer is, these things that we're looking at here are pure functions. They have no side effects. Actually, we can have functions that have side effects. There's a slightly different notation. I'm not going to talk about it
Doesn't
too
that
much.
break the functional paradigm?
Yeah. That's why it's a hybrid. Functional imperative language. So verification mostly will only happen within the functional call. That's the way to think about it. Yeah. But there's another question. If I'm let me just do it again. See if we can get it. Yeah. So here comes my point. In comes my point. Bang, bang, bang. New point. Bang, bang, bang. New point. Return point.
So you're not assigning to P, you're actually assigning to a part of P. So you've got 2 points in.
Yeah, I mean, in that sense, you could think of this, like if we think of this in Java, let's imagine this in Java space, okay? And this is an actual class point. Then what I'm doing here is I'm not assigning to a field of that object. I'm going, some temporary variable equals a new point, and I've got p.x from the old point plus my x, comma p.y from the old point. And then down here, I've got another temporary variable equals another new point, where I've got p.x from this point, that was a new point, and then p.y plus y, where p.y was from the old point. Does that make any kind of sense?
And then you return.
Yeah. Okay, so the thing about this is I've just created potentially 2 new points, right? That's kind of expensive, right? What if this was a list of points and I was updating the list? Well, I would be creating a whole new list of points, and that's potentially really expensive. The way to think about what happens is when you do assignment is it clones the whole thing, no matter what it is. If it's a list, if it's a set, if it's a map, semantically it clones the whole thing, and so potentially that can be really, really expensive. And yeah.
Copy on write?
Right. Okay. So yes. So you're jumping nicely ahead. So a lot of people ask this question from me about performance. It's a big question. They go, value semantics is great, but it's going to be really slow. But actually, it doesn't have to be that slow. And copy on write is one solution. In fact, we can do better than that, actually. And so, hopefully this will make some sense. I use this thing called reference counting, which is, it's kind of like copy and write, but it's like one step beyond copy and write, where basically we maintain a reference count for each of our objects, and we pass things actually by reference, and when the reference count is 1, we can just do an in-place update, because we know that no one else is pointing to that thing. And because of the way my types are, I can never end up with the problem you have in Java, where you have a cycle in your references, so I don't have to worry about the sort of classical garbage collection issues where reference counting is not complete because you end up with a cycle and you can't get rid of it, all that stuff. And so this is the kind of thing. So this is another kind of example. This is from a chess game, one of my benchmarks. I've got a chessboard, which is my board B, and basically what I'm trying to do is move a piece from an old position to a new position. Okay, and my chessboard is well, we can't actually even see it here, but it's a two-dimensional array, right? 8 by 8. Okay, and so the key is that when I assign null here, what I'm doing is I'm going to clone one of my arrays, one of the columns, I guess, and then I'm going to assign that, and I'm then going to clone the whole board, right? And then I'm going to do the whole thing all over again, and then I'm going to return it. So that's really expensive. But what we want to do is we maintain this reference count. So we can imagine under the hood we have a reference count for B. So when B comes in, when we do the assignment, we're going to check the reference count. And if the reference count is not 1, we're going to do the clone, okay? But if the reference count is 1, we won't clone. And what that means is, in this example, we'll do at most 1 clone. That's the most that we'll ever do. We'll make the assignment, and after we've done the clone, the reference count will definitely be 1. So there will only be at most 1 clone at that point. And in fact, what you find is that in about 90% of the cases, the reference count is always 1. Because, well, I guess I don't really know why that is, but people mostly, that's what I think about it. Things kind of flow through a function in a kind of logical fashion, and that means as a variable flows through the function, it just always has a reference count of 1. That's the way to think about it. And of course, Josh Block has also got something to say about this. This is my defensive take on the performance question. Have we got any defensive cloners in the room? Yeah? I'm a defensive cloner. I love making defensive copies. So what I will do, I do a lot of this in my compiler. I've got some data structure, some class, and it's got an array list inside it as a field. And so what I'll do in my constructor, I won't take an array list parameter, I'll take a collection parameter. And then I'll create a new array list from that collection, right? So that I absolutely know I'm the only person that has, that array list, right? No one can modify except me. But that really hits me. It hurts bad. Because what actually happens in practice? Well, most of the time, by the vast majority of the time, I start out by creating a new array list, and then I pass it into my constructor. It then clones it and assigns it to the field. And the original array list, I just chuck away. So I end up getting 2 clones when I didn't need any. And in my system, because it uses reference counting, literally there will be no clones in those situations. And so it potentially could be even more efficient. And Josh Block has talked about this in his book, Effective Java. If you haven't read it, it's really good. And he basically says, essentially make a defensive copy of each mutable parameter to the constructor as it's passed in. So he's basically saying you should clone all of your array lists when you go into constructors anyway. And if you do that, you're potentially going to be your performance will be worse than in my system anyway. So, I think I'm going to be okay. Cool, okay. Yes.
Is the cloning shallow cloning or deep cloning? So if we have an array list of array lists with values in the 3rd level, and you pass that top level array list in.
Are we talking from the point of view of the programmer's view of the world, or how I do it under the hood?
I'm thinking you're talking about you make a defensive copy. So say this array list contains.
Oh right, sorry, we're talking about Java here with Josh Block.
No, your language.
Okay.
So you'll sort of clone on the counts and all the rest, but what about the fact that the array lists under the array lists contain other values? Have you cloned them as well?
It depends. Let's answer that question. It's a good question. The answer is not necessarily no, because basically implement each of the sort of levels as a separate object. Each of them's got its own reference count.
Okay.
So I don't need to clone them in all cases. Only sort of if essentially the level that I'm assigning into and upwards, I guess is the way to think about it, is the levels that potentially need to be cloned. But then even if I'm cloning a level up and it's like a list, I don't need to clone all the other things in that list. I just need to copy them over and just clone that actual list itself.
Okay, so that's one of the Java dilemmas got rid of, really.
Yeah, there's no issue about deep cloning or shallow cloning in my language. You don't have to worry about it.
It's automatic cloning.
Yeah, that is. Well, that's right, but it's efficient as well. See, that's the beauty. It's
that's the minimum cloning needed.
Yeah, that's right, and the system makes it work. Yeah, makes sense to me, But it, people always ask. You guys have been really nice, actually. You haven't asked me any questions. Yeah.
But how are you doing your memory management out of the covers? Because how you do that is going to have a lot of impact on how efficient that memory
In what sense? Like, I mean, it's implemented on the JVM, so I'm just using, you know, the JVM memory allocation, right? There are some interesting questions about how to optimize the points at which you do the cloning and that kind of stuff. Is that sort of where you're going?
Well,
or?
yeah, but you have some types that you know don't take up a lot of room.
Ah.
And you can put them on the stack.
Okay. Okay, right. This is a good question. So the answer basically is no, but there are some types that I do, like booleans. Okay, they're just on the stack. Integers I can't put on the stack at the moment because they're unbounded, so they're actually just big integers at the moment. I have got a byte type that goes on the stack. And in fact, there are other things I could put on the stack. There's more stuff I could put on the stack than I actually do. And I have a plan for a trick, for example, to deal with the big integer problem. So the arithmetic, we're going to see a graph in a moment. The performance is not great for the language. So the problem with having a big integer is, you know, well, it's an object, right? And I want to have native arithmetic where possible. And so if you've any C hackers here, you know, if you've ever tried to do this, there's a classic C hack where you have a single word, integer, and you have a single Boolean flag. If the Boolean flag is true, then that thing's a pointer to you know, a big integer, if you like. Otherwise, it's a native integer. Right? Now, in Java, you can't do that because you can't twiddle bits and turn things into pointers. It doesn't give you that option. Okay, maybe with JNR you could do some stuff there, but it's too complicated. But in fact, for me, what I can do is actually do the same thing by splitting a single variable into two variables. One which is a native int, and the other which is a pointer. If the pointer is null, then I use the native int. If it's not null, then I use the big integer object. So in answering your question, I guess what I'm saying is there's a massive potential for performance optimizations, of which I haven't done very much. But I have lots of thoughts and plans. But yeah, the verification basically has sucked up a lot of time. I mean, you know, the demo basically went really smoothly, but a lot of effort went into making that actually work, basically. Yeah, it's a good question. Good question. Okay, how are we doing for time? Yeah, I've got a few minutes still, I guess. Yeah. Okay. So I'll quickly just talk about structural typing. If you've heard of structural typing, it's kind of, I guess it's kind of popular in some languages. Particularly if you're using a dynamically typed language, then you know it'll just make sense to you. But if you're in Java space, it doesn't make sense. And basically, what it means is that these things are not types associated with those names. Those names are meaningless. They don't mean anything, right? You know, as long as the things match up, they go together, regardless of whatever name I chose here. It doesn't matter. So in this case, I've got what I'm calling an any list, which is a list of any data item, and then an int list, which is a list of just integer data items, okay? And it's down here. And so I'm taking an integer list and I'm returning it, and the type of the return is just an any list. And that's going to go fine because of structural typing. So in Java, it wouldn't work because, you know, an int list, unless I had, you know, made int list explicitly extend any list or something weird, this would just be a type error because, you know, int list has got no relationship in Java to an any list. They're different classes, right? But in my system, well, it's going to look at actually what's inside them and go, yeah, okay, so the data field is a subtype of the data field, and int list, the next pointer is a subtype of the next pointer. Yeah, that's okay, cool. Off it goes. No problem. And, you know, that is conceptually quite a big departure from Java, and probably from quite a lot of programming languages. And I'm not sure if there are any widely used programming languages that have structural typing as their kind of core. There are a few languages like Scala has a structural typing element, and I think Go also has structural typing as well at some level, but they're not fundamental to the language, whereas in my case, there is basically no alternative. So it's very useful, but also can cause problems as well. Like if I define a, you know, centimeters integer, define int as centimeters, and I define a int as meters, well, they're going to go fine. They're just going, one's going to flow into the other, no problem, and then my, you know, Mars rocket thing is going to blow up as it tries to rotate, you know, because I used the wrong matrix or whatever. It's just one of those things. Okay, here's another example just to sort of illustrate the point a bit more clearly. Again, structural typing. So I've defined a rectangle and I've defined a border. Well, they've got the same stuff inside them. So if I take a rectangle, I'm calculating the area of my rectangle, and I can have something that was declared as having type border, or something declared as type rectangle. They would both go into that method, no problem. There's no type errors there at all, even though they've got different names. But effectively, you don't even look at the names. And if you see it like that, then it makes sense. You don't look at the names, you just look at what it's going to expand into. It's just a macro. And that's how it works. Yeah. And I guess it's controversial, maybe. I don't know. I like it. It's very powerful. It lets me construct, if you like, inheritance hierarchies that you just can't do in Java. It's just too hard to make them work. Yeah?
Do they need to be exactly the same?
No. So, like in the previous example, one was a subtype of the other. That's fine. And you can have a situation, have a notation so that I can say, let me think about this. So if I had an extra field on rectangle, then, let me think about this. No, sorry. So I have an extra field on border. Then any border thing could go into a rectangle thing, but any rectangle thing couldn't go into a border thing. Yeah, that'll be fine. And I even have a notation where you can write comma, dot, 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 and that means there are other fields, but I don't know what they are, which gives you something closer to sort of objects in a true sense. Yeah.
If border had reals instead of ints, would that still?
Yeah. So it'll do an implicit. If border had reals, then I wouldn't be able to put a border into a rectangle because that definitely would break.
Yeah.
But if rectangle had reals, then a rectangle could go in and a border could go in as well. That'd be fine, and yeah, it'll basically convert them, similar to the way the Java does it. Yeah. They are different types, so it does have an explicit coercion, just like in Java has in Java bytecode. Yeah. So it's kind of powerful. Cool. Okay, we're almost there. Okay, let's just spin on implementation. That's my compiler. It's massive. Don't worry about it. I even have my own bytecode language. It's called the Whiley Intermediate Language. It's great. Our performance. So the first thing to note here, the absolutely most important thing to note here is, of course, it's a log scale, right? Yeah. So it's really bad. What you notice is most of the things that are really bad are the arithmetic stuff, and it's all to do with the big integers. And I can probably do a lot better than that. And in fact, on benchmarks, I'm not showing any here, but benchmarks that don't do much arithmetic and that mostly do just passing around data structure and that kind of stuff, they do pretty well, actually. So